Okay, so in this section we're going to be talking about much easier. That last section was hard. This would be much easier for you. Composition of functions. What that means is putting one function inside the other. When they put that little floaty little O thing like that, what that means, it means F with G put inside like that. That's what that little floaty O thing means. It's like that. It's G put inside of F. So to make it real, that would be like me putting my toaster inside my refrigerator. They're both functions, right? What does a refrigerator do for things? It cools them, right? Yeah. What does a toaster do for things? It toasts them. So if I put my toaster inside my refrigerator, what would happen? If I put that in there and I took a piece of bread and I put it in my toaster, I know this is a weird example, but I'm trying to make real life sense. I'll put a piece of bread in my toaster, push down the lever, it's sitting in my refrigerator, and then I close the refrigerator door. About 10 minutes later, I would open the refrigerator, and there would be the piece of toast, and it would be chilled toast, right? I don't know why anybody would want chilled toast. I don't think anybody would. But my point in that is that's exactly what happens with these numbers. What happened to the piece of bread? First, the toaster did its thing on it, made it toast. And then the outer function, the refrigerator, well, once the toast popped up, once the bread popped up as toast, the toaster was done with it, then the outer function, the refrigerator, did its thing on the piece of toast, chilling it. That's exactly what's going to happen here. The -3 will go into the G machine, and the G machine will do whatever it's going to do to it, and then it'll pop out of the G machine and go into the F machine, and the outer F machine will do what it does to it, and the final product will come out. That's what it means. We're going to run the -3 through both machines, like running the piece of bread through the toaster and the refrigerator. Now, it's always right to left. That's, I hope, no surprise. That's how we always do functions, huh? If I write f of -3, you know the -3 goes into the f. We always do functions right to left, don't we? What's on the right plugs into the thing on the left. Well, it's no different when we put two of them. It's exactly the same. Right to left, right to left. So just like that. Okay, so what does that mean exactly? So now let me help you with this table. The way this table works, if you look at this top row, these are the X's, so these are the inputs. It's like what you're plugging into the machines. And then the F, this is what comes out of the F machine. And then the bottom row, the G row, is what comes out of the G machine for different inputs. So for example, if you put a 3 into the F machine, you get out 3 also. From the G machine, you get out -3 for plugging in 3. If you put a 2 into both machines, you get 1 out of F and a -2 out of G, etc. Is that good for what that table's saying? So here we go. Going to put -3 into the G machine. Okay, if you put -3 into the G machine, what pops out? Put -3 into the G machine, out comes a 3, huh? A +3 pops out, okay, like the toast pops out of the toaster, but now that +3 is going into the outer machine, refrigerator, so that +3 is going into the F. Now when you put +3, what came out of G, into F, +3, into F, you also get out +3. So +3 is the answer to part A. I took that -3, put it into G, what came out was +3, put it into F, came out another +3. Does that make sense? Want to try the part B? Let's try part B. G of F of 2. G of F of 2. So same kind of thing. Try that. So take the 2 and plug it into the F machine. See what pops out, and then put that into the G machine, and then what pops out from the outer machine is your answer. So when I put 2 into the F, 2 into the F machine, I get out 1. That's the output of F. Is that 1 there? Is that good? You find the inputs up here. Put 2, and out of the F machine comes a 1. So pop, out comes a 1. And then I put that in the G machine. You tracking with me okay so far? and put that in the G machine. So now when the 1 goes in the G machine, here's the input of 1, put it in the G machine, and you get out -1. That's what the final answer is. That's what comes out of the second machine. Is that okay?
Second machine's the final answer.
Final answer, right. That's right. Because it's right to left, and the furthest left is the final answer. Is that okay? On that, just running it through both. That's what this section is all about, is running things through two machines. Like music is composed, which means you put all the instruments together, right? So we're composing the functions. We're putting them together. Okay, these like I'm always reminding you, these are direct tests. I remember a couple weeks ago I made this exam too, and I put either the table one or the graph one on the exam. It's great that I don't remember which one, so I can honestly teach you both with full desire for you to learn both, because I don't remember which one is on the exam, but I know one of them is on the exam. I remember putting it on there. Okay, so make sure you do learn these. So, how does it work with a graph's a little tricky. What you got to remember with a graph, whenever you have F or G or whatever goes, X is I should just, okay. X is input, and the whatever answer you get, that's the output, or the Y, I should say Y. Yeah. So X is input, Y is output. That's how graphs work. Whatever's on the X-axis is what you input to the function, and whatever's on the Y-axis is the output, is the answer that comes out of it. So X values are inputs, plugins. Y values are outputs. So like I put bread into the toaster, that would be an X, bread would be X. Out pops toast, toast would be Y. Then I put toast, that Y becomes the plug-in for the refrigerator, and out pops chilled toast. Well, it doesn't pop, but becomes chilled toast. That's the Y, right? So inputs X, outputs Y. So remember that as you look at a graph. Okay, so G of F of -1. Let's just start right here. Let's just do F of -1. We'll get to the G thing in a minute. This means this is our X, this is our input. You're putting in -1, and the answer you want, what comes out, is the Y. So inputs are X, outputs are Y. That's the main key to reading graphs. And that's by common agreement. Math science world just agreed that Y values will be the Y values on a graph is where we'll put the outputs. That's just what they decided. So, okay. So if I put negative, which graph's the F graph? Top one or bottom?
Bottom.
And the bottom one's the F graph. So what you want to do is, this is an X, right? We always have X. X is always inputs. And Y is always outputs. So find, among these little dots, these different dots on the Y graph, F graph, find the one that has an X value of -1. Which of those dots has an X value of -1? This one, huh? And what's his coordinates? -1, 0. That point. That's his X and his Y. What that means is if you plug -1 in, you get out 0. Remember, the Y value connected with the X value is the output connected with that input. We put in -1, you get out 0. All these dots tell you an input-output connection. Do you see that? Like, pick any of them. Like this dot right here, what is that? That's over 1 down 2. That means input 1, get out -2 to the F machine. And on you go. So a dot on a graph is an input-output relationship to that function. That's what it is. Okay, so that means if I put -1 into F, I get out 0. So put -1 into the F machine, and according to the graph, out pops 0. And now that's going to go into G, right? Whatever comes out of the first inner function, like the toast, then goes into the refrigerator, goes into the outer function, right? So now that 0 is going to go into the G function. So look at the G graph. Now we're talking about the top graph, the G graph. The 0 here is the input to the G graph, which means it's the what? X value to the G graph. So look at the G graph and tell me which of those dots has an X value of 0. This one right here. 0, what's that, 3? Yeah, 3. So X0, Y3. So put in 0, get out 3. So we get out 3 from the final G. That good? I'll try part B there. Oops, G of F is 0. So they reverse in the order. G of F of 0. Try that one. So always start on the inside, right? We start on the inside, go right to left. So starting this, put 0 into the F graph. So that's the X value. Go to that F graph, which is the bottom one. Find the point with an X value of 0.
You already put it down though.
No, X value of 0. On the F graph. So it's this point right here, over 0 down 2. That's the X. Oh, 1, thank you. Just looking at that -2 there. That's the XY, the input-output to the F graph. So that means you put 0 in to F, out will come -1, huh? Is that good? Put in 0, out comes -1. Now, put -1 into the G graph. So that -1 is being put into the G graph, which means it's the input, it's the X. So look at the G graph and find the point with an X coordinate of -1 on the G graph. That's right here, huh? What's that, -1, +1? That's the X, Y for the G. So out comes +1. We good? Think you can do that? A little practice? All right. Oh, and that's it, huh? Are we really out of time? Well, I guess we are. All right. We will.